There you go. So how are we doing tonight?
Good, how are you?
Good. So what do we got?
Okay, we're graphing radicals.
Okay.
We just did it for like a few minutes in class just to get a start, so I don't really know much, but that's
Okay.
what we're gonna do.
Okay. Let's start
Uh,
with this. That's your elementary function.
right.
What's the domain of x?
The domain of x.
Yeah, what's the
Uh,
domain? I didn't need to even add the x. What's the domain of this function?
all real numbers, maybe? I don't know.
Well, you cannot take the square root of a negative number.
Oh, so all positive numbers.
Okay. What's the range of y of this function?
Of y?
Well, that's the range.
Everything that's equal or above 0.
Yes. So there's not going to be anything down here, down there, or down there. In other words, x can be 0 and y can be 0, but everything else looks like that.
Mm-hmm.
In other words, if you look at that function, x has to be greater than or equal to 0, and y has to be greater than or equal to 0.
Okay.
So every other radical function that they want you to graph is going to kind of be a translation of this probably. So
Okay.
what's one of them? I'll do them in blue so we can distinguish. What's the first problem you have?
Um, it would be y equals 2 root x plus 2, but the plus 2 is out of the radical sign.
It's not.
It's out of it, yeah. It's out of the radical sign.
Okay. All right. You remember transformations?
Uh, Transformations?
Yeah, there are 6 basic transformations of all of your elementary functions.
No, I do not. Oh.
Okay. Well, when you have a number multiplying the function, that is a vertical stretch factor. So if I'm plotting just that, so all I'm going to do is vertically notice that every point on the blue axis is twice as high as every point on the red curve.
Okay.
At least it's supposed to be. So this would be y equal to root x. This is y equal root x. Okay?
Okay.
Now, the only thing left is to consider that. You remember what that is? Let me give you some multiple choice. That is a horizontal shift or a vertical shift? Which?
A vertical shift.
Vertical shift. So what that means is it doesn't do anything to the shape of my curve. All it does is it moves it up 2 units. Precisely 2 units. So instead of
Okay.
beginning at the origin, I'm going to begin right there. And the curve is going to be identical to the blue curve, only 2 units higher.
Okay.
So the green curve is this function.
Okay.
Okay. Now, since you don't remember transformations, let's talk about transformations. Because you're not going to really be able to do any of these problems without talking about transformations.
Okay.
Okay? So, there are 3 vertical transformations. and there are 3 horizontal transformations.
Okay.
And it's best to remember them like this, because otherwise you have to remember 6. And it's much easier to remember 3 than 6. Okay?
Right.
Let's take the function that you just had. Okay? That is the elementary function.
Okay.
Now, there are 3 vertical transformations of that. One would be this. That is a vertical stretch.
Okay.
Another one would be this. That is a vertical shift. And the third one would be this.
Okay.
That is a vertical reflection. Now, a vertical reflection is over which axis?
The vertical or Y. Right?
If I vertically reflect that, comes out looking like this. So which axis is it over?
The X axis.
Yeah, that's an X axis. Okay?
Okay.
Oh, those are the 3 vertical. Now notice what causes that to be vertical is it is outside the function. Root x is the function. That 2 is outside the function. This is vertical because it's outside the function.
Okay.
And this is vertical because it's outside the function. So all verticals are outside the function. Let's talk about horizontals.
Okay.
That is a horizontal stretch.
Okay.
Notice it's inside the function. That is a horizontal shift. Notice that it's inside the function also, and it's not a multiplier, it's adding or subtracting. In other words, that's a multiplier, that's adding or subtraction. That's a multiplier, that's adding or subtraction. And finally, also inside the function, that is a horizontal reflection, which is about which axis?
The Y axis.
Yeah, it's the other one. Now, notice why these are easy to remember. Because you only have 3 vertical possibilities, and they're all outside the function. That's outside the root x, that's outside the root x, that's outside the root x. All your horizontal transformations are inside the function. That's inside the function, that's inside the function, that's inside the function.
Okay.
Okay? So that's the basics. And you need to memorize those 6. And it can apply to any function. It doesn't have to be square root of x. It can be x squared or x cubed. any elementary function, all of these transformations occur. So let me test you. Let me erase that. And I'm going to give you some, and you tell me what they are.
Okay.
There's two of them going on here. What are they?
All right. So
one last rule. Always do your reflections first. It makes a difference. You can do everything else in whatever order you want, but you have to do your reflections first. And it doesn't. If you have two different reflections, doesn't matter the order you do them in. Just do all of your reflections first. So if I'm going to talk about what that transformation is, what is it?
Vertical.
Okay, so it's a vertical what?
Reflection.
Good. That's doing that first. Plus what else is it? Is that outside the function or inside the function?
Outside. So that'd be
vertical or horizontal?
Horizontal.
No. Everything outside is vertical. Everything. So whatever it is, it's vertical. Now, is it a shift or a stretch?
It's a shift.
Yeah, shift doesn't change the shape of the curve. In other words, if I have a parabola, y equal x squared, and I say, well, what is y equal x squared plus 2? Then I just take my y equal x squared and I move it up 2 units, and it looks exactly the same shape, only it's up 2. So shifts, whether vertical or horizontal, do not change the shape of the curve. Stretches do. If I were to put that 2 in front of the x squared, like that, then it would change the shape. It's not the same parabola. Just moved up 2, it's a much narrower parabola, like that. So that's the difference between a shift and a stretch. A stretch, think of as if you have a rubber band and you're pulling up, or you have a string that's in this shape, and you decide to pull up on both ends of it. That's going to change the shape of it, right? So when you change the shape, you're doing a stretch. If you're not changing the shape, you're doing a shift. Shifts also are added or subtracted. Stretches are multipliers. Okay. So we have two things going on with this function. First thing, vertical reflection. Second thing, vertical shift. Do them in that order. So if I were to graph that, here's the elementary function. First thing I do is which?
You graph the vertical shift?
Nope. Always do your negative signs first. Your reflection.
Okay.
Always. They have to be done first. There's the vertical reflection. That is y equal negative root x. With me?
Okay.
Now I got to apply the vertical shift. What's that going to look like?
It's gonna be,
Which color line and what do I do with it?
okay, so it would be the, not the blue one, right?
No, it is the
Or
blue one. In other
it
words,
is?
we do these in order. The red one is the elementary function. The red one is y equal root x. So the
Right.
first thing we apply is the negative sign. That gives us the blue. But that's not the one we're dealing with. We're dealing with negative root x plus 2. So we have to apply the plus 2, which we've already decided is a vertical shift. So how do I vertically shift this by 2 units up?
Shift up two, or?
Exactly. In other words, it is the way to say that verbally is you take the blue line and you move it up 2 units without changing its shape.
Okay.
Shape is exactly the same. So the
Okay.
green line represents that function. And that's all you do with transformations is you do them one at a time. Okay? You might get some functions that have all 6 transformations. How about this? That's got all 6 of them. It's got a negative sign in front. That's a vertical transformation. It's got a negative sign inside the function. That's a horizontal reflection. It's got a multiplier. The only one I didn't add is another multiplier there. There, now it has all 6.
Mm-hmm.
So you can have all 6 in one function, and you just do them one at a time. That's all you do. And you always do
Okay.
your reflections first.
Okay.
Now, we can go 2 ways from here. We can have you give me some. That's probably the best way to do. And we'll graph them one transformation at a time. So give me your function.
Okay. All right. Here's one. Where is it? All right. Y equals root x plus 10.
Okay.
And that's it.
So we start out with the elementary function, which is?
Vertical.
Now hold on. What's the elementary function?
Y root x.
Okay. Let's graph that. Looks like that. Okay?
Mm-hmm.
Now, there's only one transformation taking place here. It's that plus 10. But you have to know what that does.
Mm-hmm.
What is that called? I'm going to give you some multiple choices. Is that a vertical shift? Is that a horizontal shift? Is it a horizontal stretch or a vertical stretch?
A horizontal stretch.
It's a horizontal shift. Notice that it's being added.
Okay.
Stretches have to be multipliers.
Okay.
So whenever you're adding or subtracting a number, it's a shift, which makes it the easiest because it's not going to change the shape of the curve. It's just going to move it. Which way? Left or right? It's horizontal, we know, because it's inside the function. That makes it horizontal. Everything inside the function is horizontal. Everything outside is vertical. So it's a horizontal shift. Is it to the right or to the left?
To the left.
Yeah, very good. So instead of starting at the origin, we're going to start right there. We're going to have a curve that's essentially the same exact shape as that. As all we did was we moved the starting point 10 units to the left. If that were to say x minus 10, then that's a shift to the right.
Mm-hmm.
Okay? What else you got?
Okay, here's one. Where is it? Alright. Y equals root 3x plus 6, and then out of the parentheses plus 1.
Like that?
And then plus 1 outside.
Okay.
Yeah, that.
Now, there is a little bit of trickiness here. In other words, what I'm going to do is factor out that 3, make it look like that. Okay. Now, we have 3 transformations here. You have this one. What does that do? First of all, is it horizontal or vertical?
Vertical.
It's inside the function. What does that make it?
Horizontal.
Okay, so that's horizontal. What is this one?
A vertical. Or horizontal.
Okay. That's why I want you to remember them as 2 types, horizontal, vertical, inside the function or outside the function. Because then you only have to remember 3 things. Okay? Now, this first horizontal, is that a stretch or a shift? Stretch
That'd be
multipliers, shift, no.
Shift. Or stretch.
Multipliers, shifts are added or subtracted.
Okay.
So that's a stretch.
So, stretch, yeah.
Okay? What's the plus 2?
That'll be a shift.
And finally, what is that? Vertical or horizontal?
Vertical.
And is it a shift or a stretch?
A stretch.
Is it added or multiplying?
Okay, so it's a shift. It's added, so.
Remember, all stretches are multipliers, all shifts are added or subtracted. Okay, so we're going to take each one of these at a time. Let's start there. There's no reflections, right? There's no negative signs anywhere. So we don't have to worry about order. We can do them in any order we want, as long as there's no negative signs. If there's negative signs in front of the x or in front of the function, we have to do those first. So to do a horizontal stretch of my blue line, I have to make every point on the blue line be 3 times higher, like that. In other words, if that comes at 2, then that comes at 6. With me?
Okay.
Yeah, I didn't explain it right, though. That's a vertical stretch. Let me start over. That would be a vertical stretch. This is a horizontal one.
Okay.
Now, this is particularly confusing because horizontal stretches compress the function this way. It's like if you put your finger on that piece of string and pushed.
Okay.
It does result in something that looks like that. Okay?
Okay.
So the green line is y equal that. That's all it is.
Okay.
Okay. Now, the next thing we're going to apply is the second transformation we come across, which is a horizontal shift of 2 units. What's that going to cause me to do to my green curve?
Move it back to, or up to,
Is it horizontal
or
or vertical?
horizontal, so to
So
left,
on left and right. You're talking
left,
vertical, you're talking up or down.
right, so left 2.
Okay. So I start my green curve right there, -2, and I draw it without changing its shape, like that.
Mm-hmm.
I only have one last thing to do, this one right here. What is that going to do?
Move it up 1.
Right. It's a vertical shift, doesn't change the shape. I start with my point that I knew where that point was from the start. It was at the origin.
Mm-hmm.
So that's my point of reference that I move about. Okay?
Okay.
So I'm going to move that up exactly 1.
Okay.
Now that curve is exactly 1 unit above the red curve
Mm-hmm.
at all points. And that's the final curve. In other words, I can erase the red, the green, and the blue. The only thing I have left is the orange, and that is that function right there.
Mm-hmm.
Notice that this function is defined at -2. I can take the square root of 0. And when x is -2, y is 1.
Mm-hmm.
That's that point right there. And then everything else goes up and to the right.
Mm-hmm.
All right. That's a good start on transformations. Transformations are difficult for a lot of people. And that's why I cannot stress enough separating them into horizontal and vertical. Once you do that, they actually become rather easy because the negative sign is treated entirely different than anything else. So then you're only left with horizontal stretches or horizontal shifts, or vertical stretches and vertical shifts. So
Mm-hmm.
if you break it down into memorizing pieces of it, you don't memorize 6 transformations. What you do is you memorize it in 2 groups of 3.
Mm-hmm.
Okay? Blake, I will let you go, and I will talk to you next time.
You too, bye.
Bye-bye.